This is Mrs. Appio with Lesson 1 from Grade 8, Module 3 on Similarity. You don't need to include this in your notes, but I wanted to go over what this module will be about. Where we're going with Module 3 Similarity. Topic A begins by demonstrating the need for a precise definition of dilation instead of same shape, different size, because dilation will be applied to geometric shapes that are not polygons. Students begin their work with dilations off the coordinate plane by experimenting with dilations using a compass and straight edge to develop conceptual understanding. In Lesson 1, dilation is defined and the role of scale factor is demonstrated through the shrinking and magnification of figures. In Lesson 2, properties of dilations are discussed. As with rigid motions, students learn that dilations map lines to lines, segments to segments, rays to rays. Students learn that dilations are angle-preserving transformations. In Lesson 3, students use a compass to perform dilations of figures with the same center and figures with different centers. In Lesson 3, students begin to look at figures that are dilated, followed by congruence. In Lesson 4 and 5, students learn and use the fundamental theorem of similarity. Students verify this theorem experimentally using the lines of notebook paper. In Lesson 6, the work with dilations is tied to the coordinate plane. Students use what they learned in Lessons 4 and 5 to conclude that when the center of dilation is the origin, the coordinates of the dilated point are found by multiplying each coordinate of the ordered pair by the scale factor. Then Lesson 6 is followed by a mid-module assessment. This is Lesson 1, What Lines Behind the Same Shape. Pause the video and copy the essential question. What does it mean for two geometric figures to have the same shape but not necessarily the same size? In our exploratory challenge, two geometric figures are said to be similar if they have the same shape, but not necessarily the same size. Using that informal definition, are the following pairs of figures similar to one another? I'd like you to pause the video, write down your answer and your explanation for this page, and then resume the video to check your answers. The triangles appear similar. One is just larger than the other. No, one is a square, the other is not. For pair C, they appear to be congruent. And just a reminder, two figures in a plane are congruent if there is a congruence that maps one figure onto the other. And for pair D, the circles, they are the same shape, but one is smaller than the other, so they appear to be similar. On the next page, pause the video and answer whether you think these are similar or not and your reasoning. Then resume the video to check your answers. Pair E appear to be similar. They're the same shape but different sizes. Pair F appear to be similar. One is smaller, but the faces look the same. Pair G, they don't look similar. One of them is squished. And pair H, they don't look similar because one of the curves is distorted. So now let's take a minute and look at the definitions of these terms. The definition of similar. These are two figures in a plane, are similar if there is a similarity transformation, taking one figure to the other using basic rigid motions or dilations. Pause the video and copy the definition. Now, the definition for dilation. This is a transformation that shrinks or magnifies a figure by multiplying each coordinate of the figure by a scale factor called R. Pause the video and copy the definition. All right, so let's take a look at the first pair. We've got a smile face and then a smaller smile face. This is called a dilation, and our scale factor is greater, or rather, our scale factor is less than 1. When your scale factor is less than 1, it shrinks the picture. In our second picture with stars, our second figure is larger, so this one has a scale factor greater than 1. When your scale factor is greater than 1, it magnifies your picture. When the pictures are the same, then your scale factor is equal to 1. And recall that a scale factor is just a ratio comparing the segments from one figure to the corresponding segments in the other figure. Number 1, given OP equals 5, and that means the length of segment OP is 5. If the segment is dilated by a scale factor of r equals 4, what is the length of segment OP prime? So let's take a look at what that might look like. Here is segment OP. And it says that it's dilated by a scale factor r equals 4. What is the length of the segment OP prime? If we're going to take this segment and we are going to multiply it by a scale factor of 4, then it will be 4 times longer than it is now. And it is 5 inches long now. So we take our scale factor and we multiply it by the original length, and that tells us the dilated length. Again, the dilated length is equal to the scale factor of r multiplied by the original length. And so that's just 4 times 5, and the length of OP prime will be 20 inches. If segment OP is dilated by a scale factor of 1/2, what is the length of the segment, OP prime? The scale factor is 1/2, and the original segment is 5, then the dilated length will be half of 5, which is 2.5. So OP prime in this case will be 2.5 inches. Using the diagram below to answer exercises 2 through 6, let there be a dilation from center O. Then a dilation of P equaling P prime and a dilation of Q equaling Q prime. In the diagram below, the measure of OP equals 3 centimeters. So the distance from O to P is 3 centimeters, and we are going to use a scale factor of 3 to dilate that segment. And OQ is 4 centimeters. Here's OQ, and that is 4 centimeters. So the scale factor r equals 3. What is the length of OP prime? The length of OP prime is equal to the scale factor times the original length of OP. OP prime is equal to the scale factor of 3 times the original length, 3. And so the answer is 9 centimeters is the length of OP prime. OP prime is that long. Question 3. If the scale factor r equals 3, what is the length of segment OP prime? That's the exact same question, so let's turn to the next page. Use the definition of dilation to show that your answer to exercise 2 is correct. The definition is right here. Let's just write it above it. This is the dilated length is equal to the scale factor times the original length. So that is our explanation. That's how we know our answer is correct. The dilated length, which is OP prime, is equal to the scale factor, which was R, times the original length, which was 3. Question 5. If the scale factor R equals 3, what is the length of segment OQ prime? Right, so let's just redraw our figure here. And we have O, and we have Q, and we have Q prime. And we know that this distance was 4 centimeters, and it says R equals 3. And remember, that is our scale factor. So we know that our dilated length is equal to the scale factor, which is R, times the original length. And if you write this down a few times, it helps you to memorize it. Right, so our dilated length, that's going to be OQ prime. Our scale factor is 3. And then the original length, that's OQ, the length of OQ. So we have the length of OQ prime equals 3 times the length of that segment, which is 4 centimeters, and 3 times 4 is 12. So the length of OQ prime, which is our dilated segment, is equal to 12 centimeters. Use the definition of dilation to show that your answer for number 4 is correct. We've actually used the definition as we wrote out our solving the problem. Question 7. If you know that OP equals 3, okay, let's go back here. It says you know that the length of OP is 3. Here is O, here is P, and we know that this is 3. And you know that the length of the dilated segment, OP prime, is equal to 9. How can you use that information to determine the scale factor? Well, let's use our equation. We know that the dilated length, which is OP prime, is equal to the scale factor times the length of OP. And we know that OP prime is equal to 9. And we know that the length of OP is equal to 3. And then you would just need to solve that equation. To solve that equation, you would divide by the length of the original segment. And that would give you an answer of 3, and that is your scale factor. In this lesson, you have learned that a dilation magnifies or shrinks a figure using a scale factor, which is called R. When the scale factor is greater than 1, it magnifies the picture or makes it bigger. When the scale factor is less than 1, it shrinks the figure or makes it smaller. If the scale factor was equal to 1, then your picture would be exactly the same. Remember, the length of the dilated segment is equal to the scale factor times the length of the original segment. The dilated segment would have a prime symbol after the point. Scale factor is called R, and the length of the original segment would just be called OP. And remember that O is the center of dilation. The O is the center of dilation. And let's just take a look at that on our picture as well. Here, O is the center of dilation. That concludes our lesson 1 from this module.